Good morning. This is AVT 140. This lecture will be for Wednesday, March 18th. I'm going to try the YouTube route for some of these lectures here, mostly because I think a lot of the material we're covering really can't be adequately learned with just PowerPoints and a little bit of narration over the top. I really think that it needs to be looked at. So we're going to give this YouTube stuff a try here, especially as it relates to the navigation problems and the E6B type calculations. So hopefully it goes well and we're able to adequately learn the material like we would otherwise be doing in the lecture. If there are assignments associated with a particular lecture, I will inform you in the introduction portion of this video. Like right now for this particular lecture, there will be some questions loaded in Blackboard. It will be a Word document that I'll upload in the learning modules section there. So if you would go in there and answer those questions. If it's going to be a discussion board, I'll go ahead and let you know that it's going to be a discussion board. So everyone's on the same sheet of music as we work through this process here. So bear with me. I muted this whole video editing thing. Hopefully everything turns out good and we're able to keep pressing as usual, just in a slightly different medium. So here we go. So if y'all recall from the last slide of that PowerPoint lecture, I was asking you all to do a planning exercise and it's going to take you straight line from Terre Haute Regional Airport down here to Evansville Regional Airport. Now, before we really get into the nuts and bolts of doing that planning exercise, I'm going to show you all an equation. I guess you can sort of call it an equation here, that's going to walk you through, allow you to keep all of those factors you need to take into account when you're doing those corrections and put them in a nice logical format. So the first thing we're going to get from our sectional and our plotter is going to be what we call our true course. Now remember that on that sectional chart, everything's in true. We need to convert it to magnetic to get some useful thing that we could actually fly off of in the aircraft, since our compass is going to be in magnetic. Also recall that when you get those winds aloft, those are also going to be given to you in true. So the first correction we can perform is going to be that wind correction angle, which we'll use the back of the E6B to perform. All right, so for the sake of the equation, we have our true course, and I need to apply our wind correction angle to that true course. All right, now if you recall, when you're looking at the back of the E6B here, any figure that's to the right of that center index line is going to be additive, and any figure that's going to be to the left of that course line is going to be subtractive. So as we're building our little equation here, we can go ahead and say minus left plus right. Those are going to be the corrections we make to that true course with our wind correction angle. And that is going to give us what we're going to call our true heading. All right. Once we get that true heading, we need to start converting it over to magnetic. Now, in order to convert it over to magnetic, we need to look at those isogonic lines we talked about. Now, if you look in the vicinity of Terre Haute, we come over and we find that magenta line. That's going to be the isogonic line for the particular region that we're operating in. And we can see that when we look at that isogonic line, we get a correction factor of 4 degrees to the west. So coming back over here to our board, we can go ahead and apply that magnetic variation. Now remember the little moniker, east is least, west is best. So we will subtract east and we will add west based off of that variation. And then that is going to give us a value that is going to be our magnetic heading. And once we determine that magnetic heading, we will then apply what's called compass deviation. Now, compass deviation is going to be unique to every aircraft. It's going to be interference caused with that compass through the actual structure of the aircraft or with the electronics in the aircraft causing some sort of magnetic interference. So again, subtract east, add west for that deviation. And that'll give us the value that we are actually concerned about, which is going to be our corrected heading. So first thing, we find our true course, subtract left or add right or wind correction angle to get our true heading, look at our magnetic variation, subtract east or add west to give us our magnetic heading. Then when we come to the deviation, we're going to subtract east, add west again to get us the corrected heading, which we're actually concerned about flying in the aircraft. When it comes to the deviation, oftentimes when you're doing your flight planning, you're not going to know what that deviation is just yet. So for all of our planning purposes, we're just going to go ahead and assume a deviation value of 0. That'll help keep things kind of simple. So go ahead and jot down that equation. We'll be referencing it several times today. So let's get back to our problem here. The Terre Haute, the KHUF, down here to Evansville, Kilo Echo Victor Victor. All right, so let's go ahead and get the information we're going to need to run through that equation we just talked about, which is going to be that true course. And while we're laying our plotter in between those 2 points, we'll also go ahead and draw a course line, and we'll go ahead and get what the overall distance is going to be. So to accomplish that task, we're going to go ahead and line up those 2 points of the plotter. So in this case, we're going to take the end point of the plotter, we're going to line it up here on Terre Haute, and we're going to come down to the bottom, and we're going to line it up here with Kilo Echo Victor Victor, or Evansville. Now, lucky us, these 2 points were selected, and they are basically covering the entire scale along the plotter. So let's go ahead and grab that easiest bit of information to get first. We look along the nautical mile scale here of our plotter. Make sure we're choosing the right one. We're looking for the sectional scale, that 1 to 500,000 scale. And we come all the way down and we find Evansville, and we can see that it is going to be 85 nautical miles. So on another piece of paper over here, I went ahead and have mine set up with that equation we just looked at. I also have our givens, that 120 knots true airspeed that we were given for the situation. And I also got the winds that we were given, that 270 at 10. So right here in the distance, let's just go ahead and jot down what we got from that initial plotter line, which is going to be that 85 nautical miles. The next piece of information we want to get while we have our plotter laying here is going to be that true course. Now, depending on what type of plotter you have, this might be a little more difficult, but if you have a plotter like this with a rotating bezel, it's actually quite easy. So what you want to do is you want to go ahead and line up those lines that are on that rotating portion of the plotter, and either line them up with or get them approximately parallel to lines of latitude and longitude that happen to be on the chart. All right, now we can see from this particular line of longitude here, we get that little plotter circle lined up to where it's approximately parallel with it. And then we take that information, we come down here and we look at our true course line, which we can see in this case is going to be a true course of approximately 190. So that's the value we're going to take over here, and we're going to plug that into the first little section of our equation. After we get that information, we're going to take that true course, and then we're going to take the winds that we were given, that 270 at 10 knots, and we're going to perform the wind correction angle calculation using the backside of the E6B. So we get our E6B out, we go towards the wind side. All right, now we need to actually spin in the course of those winds and plot the wind velocity. So you're given the winds of 270 at 10, so we need to place 270 under our true index. So there it is, 270 under our true index. Next, we're going to use our grommet to serve as a reference point. I like to use 100 just because it makes the math easy, but as long as you park on any major reference that's going to allow you to note the velocity of the winds, it's going to work out the same. So in this case, we have it parked at 100 with the true index at 270, and we're going to mark up 10 knots. So in this case, we're going to make our little X for our winds there at the 110 index, just to show that we are looking at a wind velocity of approximately 10 knots. The next thing we're going to want to do is we're going to want to look at that true course that we got from our plotter, which we determined to be 190. So under our true index, we're going to plug in that 190, and then we were given that true airspeed of 120 knots. So we want to move our sliding scale up or down until our wind dot is parked there on 120. Now we get 2 pieces of information from this one, so we get that wind dot on that 120. We get our wind correction angle, which you can see from the location of our wind dot here. Hopefully you can see it from the glare, but it's going to be 5 to the right. So we can take that 5 to the right, we can plug it in over here at our wind correction angle. So we can go ahead and say 5 degrees, and it's going to be to the right. So that's going to be an additive factor. Coming back to the wind side of our E6B, we also get our ground speed, which is going to be located underneath our little grommet here. In this case, we can see that our ground speed is going to be approximately 118 knots. So let's come over here, and we'll go ahead and jot down our ground speed of 118 knots. So now we actually have all the information that we need to complete this calculation here. We can go ahead and figure our corrected heading based off the information we already have. So we have that true course of 190 and a wind correction angle of 5 to the right. So that'll give us a true heading of 190 plus 5, or a true heading of 195. Now we need to bring that variation back into play. If you recall, that isogonic line we found near Terre Haute was going to be a magnetic variation of 4 degrees to the west. So in this case, it's going to be to the west, so it's going to be additive, and we said it's going to be 4 degrees. So therefore, to get our magnetic heading, we take that 195, we add 4, so we get a magnetic heading of 199. Now recall when we were looking at the marker board up there, we said for our planning purposes, our deviation, we're just going to go ahead and count on it being 0. So 199 plus 0 gives us a corrected heading for our straight line route from Holman down there to Evansville is going to be 199. When we spun those winds, we also got our ground speed. We determined that our ground speed was going to be 118 knots. And we also determined with the plotter that our distance between Terre Haute and Evansville was 85 knots. So what we need to do now is we need to go ahead and go to our calculator side of our E6B flight computer. So the first thing we need to do is we need to take that ground speed, that 118, and we need to place that 118 ground speed over our 60-degree index. So we'll go ahead and spin that in. We'll go ahead and park that index over 118. Now recall that the E6B does not give you zeros or decimal places, so it's up to you to keep track of them. So we find about that 11.8 index mark, and that's going to be 118. All right, so we know our distance is 85 nautical miles, so we're going to go find 85 on the A scale. That's going to be the outer scale. There's 85 right there, and then we need to go ahead and come to our inner scale. All right, we can see there it falls somewhere around the 44-minute mark. There's 40. So we have 41, 42, 43, 44, and then there's our 45 index there. So for 85, we can go ahead and say that that leg time is going to be approximately 44 minutes. So given the ground speed of 118 and the distance of 85 nautical miles, we can go ahead and say that our time en route is going to be approximately 44 minutes. So we've worked out our time we said earlier was going to be 44 minutes. So let's go ahead and do a quick fuel calculation here. Let's go ahead and arbitrarily say that our flight manual said that given the altitude and the true airspeed we were going to fly at, our total fuel burn was going to be approximately 8 gallons of fuel for every hour. We've determined that our time en route from Terre Haute to Holman is going to be 44 minutes. So we'll go back to the calculator side of our E6B here. In this case, we're going to put our fuel burn over our 60-degree index. So we said it was going to be 8 gallons an hour. So we'll go ahead and use the 80. We'll go ahead and say that's going to be 8.0. Now what we need to do is we need to go to our B scale for time, find 44 minutes, there it is, and then come back out to our A scale to figure our approximate fuel burn. So there's 55, remembering that that's going to be 5.5, 5.6, 5.7, 5.8, and since it's falling somewhere in the middle there, we'll just go ahead and round it up and say that for that particular leg, we're going to need 5.9 gallons of fuel. Now keep in mind we also need our day VFR reserves of 30 minutes of flying time. So half of 8 is going to be 4 gallons for that 30 minutes of flying time. So we add the two together. Our total fuel required for that particular leg to be legal with the VFR reserves is going to be 9.9 gallons of fuel.